Hey guys, I wanted to jump right back in and keep working on my correlation and my regression here. So I think last time I showed you guys this correlation. So I have this executing. I had to use, because I had not their data, an NA. I had to use this complete.obs. And it gives me this correlation value. What I wanted to show you guys next was that I can take that same code, essentially the same code, and add core.test, and this will do a hypothesis test of the correlation for me. So it'll compute the t-value, the degrees of freedom, and the p-values. So remember that the correlation what we're looking for is the null hypothesis is that the correlation is actually 0. There is no correlation. And the alternative hypothesis is that the true correlation is not 0. At least in this one, that's what I've done, not equal to 0. You could, of course, do a one-sided test here that the true correlation is greater than 0. You see here my 95% confidence interval goes from 0.8 to 0.95. So 0 is not included, so I would reject the null hypothesis. And this also gives me that same correlation value. So that's kind of cool. All right, so and that's the points with wins. So points versus wins with the X and the Y. Okay, so the next thing that I wanted to do was I wanted to well, let's open this document, right? So I just did part C there with just core.test. I wanted to use a categorical variable and repeat the regression on a subset of the data and plot together and talk about the appropriateness on the restriction. So I did not have another good categorical variable, but there was a categorical variable that I've been playing around with that I hadn't called categorical yet. I kept playing around with this more power play opportunities than power play opportunities for opponent or something. And so I wanted to ask, I kept wanting to ask if you have more, do you need to stay out of the penalty box? So what I've done here is I did this data which, so you guys saw this command the other time, and before I just put a comma and then closed the square bracket. And that got me, maybe I'll show you guys where that got me. Well, let's do it right here. So if I do, I want to be lazy, I'm going to copy and paste. There we go, close that square bracket. So this would give me the whole data set, and you see there's some values that are missing, right? I'll have 14 rows instead of the 31 that are normally there. What I'm going to do next is I'm going to ask it, so what I can put in here in this last column is I can put in any one of my variable names. So say I want to put games played. It would just return how many games played they have. But what I've done in this next category is I've created something that wasn't there. More power plays than kills. MPP than kills. I don't know, crazy name I picked. But so the team that had more, I called them true. And the team that didn't have more, remember the exclamation point is not, I called that false. And so when I run that, my data now has a new column that will be just that. Let's show it. It will be that more power plays than kills. See how it came up there? And it's going to say, false, 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 true, right? So we can see then, and then NA, that's the last team that doesn't have any data in this set. So we get to see then a categorical variable. So I introduced a categorical variable based on my quantitative variables. And you can always do this. You can always add more variables. So I sliced the data and I added a new variable here based on how I sliced the data. Kind of cool, just trying to show you guys some ways you can play with your data. Okay, so now I want to create a linear model and use this. So I can do this in a couple of ways. what I'm going to suggest here is I'm just going to go ahead and I'm going to do a linear model. The linear model is LM. We're still going to be trying to predict W's. We're going to try to predict W's based on points. And now I also want to do it on MPP then kills. And we're going to do that with our data. So this is going to give me a linear model that is going to have a categorical variable in it. So we're going to still have an intercept. We're still going to get about, for every point we'll get about a half a win. And if we have more power plays than true, we'll also gain about 0.28 points. This is true. If it's false, we just have the intercept. So it's like an indicator here. So if it's true, you get that. And maybe I should run a summary of this and see if it's statistically significant, these new things that I did. By the way, I normally like to call this like fit or something. So let's run that again. Let's also print it, because I think it looks pretty when you print it. And I'll run the summary of this fit. There we go. Boom. And we see that in this case, it looks like everybody is statistically significant, at least up to the 5% threshold. So they all look like they're important in the formula for wins. So I think that's kind of cool that you can actually see that teams will gain about a quarter point, and this is a very early part of the season, if they stay out of the penalty box. So it was a cool way to do it. And again, the way I did it here was I added that categorical variable right here. Now, if your categorical variable has more than just true and false, which it most likely will, it'll include all of them but one. So because mine's true and false, it only needed to include one thing, but if you have, say, 10 categories, it would include 9 different variables here. So this table in particular can get pretty hairy, but you can kind of look through it and see which ones are important really quickly. All right, so that is how I would do that. And that's how I would compute a multiple regression using an indicator. And I should compute a prediction for at least 1 point, huh? So let's make up a fake team, huh? So let's see, if we want to do a prediction, we need to do y. We're going to assign that as a data.table, and we're going to say on this table, what do we want to say? We want to say that P to S is equal to, let's say they have 10 points, and then we also need to say that MP then kills, let's say that equals false. I have to assign it a different thing, and so I'll predict, I'm going to spell it right, I'm going to predict from my fit, I'm going to predict the y. What did I do wrong? Sorry guys, I got an error. I needed to call it data.frame, not data.table. I did not figure I was going to do that right first try. There you go. Yay! Okay, so I would predict that this team would win 4.8 games. And I don't know, you can play around with this, right? So how many games do they win if they stay out of the penalty box? Oh, look, they win an extra game there. Yeah, we kind of knew that already, right? So I find this kind of cool. I think this is a great way to use it. So there you go. Let's see. I'm thinking about trying to graph it. How do we do our graph above? So above, when I did my graph, where'd it go? It's right here. We just did the plot and we did the AB line of the model. Let's see if we can do that. I'm copying and pasting because I'm being lazy. Here I am down here. Oops. And I want to do the AB line of the fit. I called it model above. I called it fit down here. And it is not able to use that. There's an error here using only the first two of the three regression coefficients. So it wasn't able to use that second regression coefficient because it wasn't available to it. Trying to use that. I don't think I can. Color equals. Color is not a graphical parameter. Let me pause.